Yes, hello guys. Today let me start my first lecture on integral calculus. Before taking these questions, these are for just elementary introduction to the integration, okay, or integral calculus. And before that, I'll just discuss about what is integral calculus, okay, and what is the process of integral calculus, what is the constant of integration, okay, and what is the general process of integration. We'll discuss about. Okay, then how to find out the integration of a product of a constant and a function. Okay, then I'll discuss about how to find out the integration of a sum or difference of two or more than two functions. Okay. These are the 4 or 5 or 6 points which I have to describe first, and after that I'll take these questions. These questions, as I always say, I've taken these from students queries in the class as well as online students who have asked me. The important, mostly the last question or some of beginning questions, they were asked by students online. So I've taken all these questions just to reply here. Okay, they are based on integration. Okay, initial integration. Let me just introduce what is integration and how integration is the process of just how later it was discovered that okay, integration is the anti operation which is just reverse to differentiation. Okay. It was later found, but initially integration was considered as a, it was discovered by, or it was just a combined effect of, it was outcome of the attempts made by different mathematicians or number of mathematicians to find a method, general method, to find the sum of area, okay, bounded by plane curves, bounded by number of plane curves, and so to find the sum of, to find the general method, how to find out the area of a plane, okay, bounded by plane curves or bounded by curves. Okay, that was the initial attempt made by mathematicians. So in this discovery, the integral calculus was discovered. Okay, this is the process of integration. Okay, initially there was they attempted to find out a method to find the sum of the area. Find the area, some general method to find the area of a plane which is bounded by plane curves. Okay, so in that way, this was the initial attempt of the mathematicians. Secondly, okay, and then later it was found. Okay, and how? Okay, initially when they were finding out the method of the area, to find the area of a plane, in that way they were initially dividing this whole plane into number of small elements. Okay, very small elements. Okay, and the number was increased, and then these small elements, their areas were found out as a sum and the limit of a sum. This I discussed in definite integral. Okay. For the limit of sum, the definition of integral calculus is discussed repeatedly in undefinite integral. So that is the topic of definite integral. But initially, definite integral was the main motive of the mathematicians. So in this discovery, the integral calculus was discovered. So and you will come to know, and this is just important for those students who are finding out that okay, later it was discovered that integration or integral calculus is the just reverse operation of differentiation. Alright, this was later discovered. But and the students who are very interested in knowing that which one was first discovered, integral calculus was the first subject which was discovered first. After that, differential calculus followed. Differential calculus is the later product. Integral calculus was first initially discussed, okay, and that was first discovered, and after that, differential calculus was discovered later. So this is how their relationship is. So integral calculus is the first method, first subject which was discovered, then differential calculus was followed. This is what I have to discuss about. Okay. Then what is the process of this? Done process of this method. Let me write down something that one can write. Let me introduce. This is an introduction. Let me first find out what is introduction. Introduction to integral calculus. Introduction to integral calculus. Okay, so what is introduction? As I just told you, that it is the outcome of the combined effect of attempts made by different methods. This, let me write here. It is the outcome of the efforts made by number of mathematicians. Number of mathematicians. Number of mathematicians who were attempting to find a general method for finding the area of a plane, find the area of a plane bounded by curves. Bounded by curves, or let me take plane curves. Bounded by plane curves. This was the attempt with like mathematics initially. Okay, so they were dividing the whole. They were dividing the whole area, into a number of very small elements, very small number of elements. Then the sum of the areas of these small elements, okay, these small elements was found out as a limit of a sum, as a limit of a sum, as a limit of a sum of these small areas of these small elements, which were, let me write here, which were very small in size, but increased in number, increased in number. Okay, this we will discuss when we will be at the limit of a sum. We will discuss this in the definite integral, okay, lecture of mine. So there I discussed that how the limit of the sum of a plane area is to be calculated. That we will discuss there. Okay, so this is how. So it was later discovered. That the process of integration is the operation just the reverse or just inverse of just reverse or inverse of the process of differentiation. But initially the word to integrate To integrate. To integrate means, okay, initially the word to integrate means or meant is still means, okay, or literally means, let me take to integrate, okay, word literally means meant, literally meant to find the sum of, this is to find the sum of, so this is summation sign. So integration sign was initially taken as this one. To integrate word literally meant to find the sum of, okay, or before it was found to be inverse process of differentiation. Inverse process of differentiation. Inverse process of differentiation. Okay. The word integrate was taken as summation, or to find sum of, okay. So because of that, the letter which is used to integrate, okay, that symbol which is used is taken from S, the sum, the first letter of sum, SUM sum, the integration sign which is elongated S, okay, that is used for integration. This is elongated S here, sign of integration. All these are sign of integration. This sign of integration is elongated S because this is taken from sum, the S, the sum of, okay, the sum of, to find the sum of, okay, so, or summation of, find the sum. It was found the sum of all the small areas of all the small elements to comprise the whole plane area. Okay, so that was the initial meaning of this. Okay, so that was still it is, okay, the symbol is used which is taken from S elongated. This sum of, find the integration of something, find the sum of something. That was initially meant. Okay, so for those students, for those viewers, let me note down this. For those viewers who are interested to know about the origin of integral calculus, okay, they should know that it was integral calculus. Which was discovered first. Which was discovered first. Then differential calculus followed later. Then differential calculus followed. later. Okay, so this is some bit into means first in integral calculus I discovered, and after that in the process of this I found this reverse of differential calculus, but differential calculus was later is the later product. Okay, this is what you have to know about it. Now let me talk about next thing, that what is the integration that means. So this as sign which I have just discussed about, that what is the sign of integral. Okay, introduction to integral calculus I have just discussed about. Now let me, what is the definition of the integration? Let me talk about what is the definition of integration then. So definition of integral of integration. Let me definition of integral or integration or integration. Definition of integration or integral. Let me define it. Okay. Now if I say that if, let me take, if fx be the differentiation of or differential coefficient of or let me write here differential coefficient of or differential coefficient of fx. Okay, fx, that is ddx of fx is equal to small fx. Okay, then this fx is known as integral. Okay, integral, or then let me write here capital Fx is the integral one thing, or antiderivative or the primitive of fx. The primitive of fx. So fx is the integral or antiderivative or primitive of fx. Here this fx is the, our target will be, that means this implies that if I find out the differential integral this fx into dx is equal to fx. So here fx is the integral or primitive or antiderivative of this fx function. So this is how we represent it. Okay, here fx is the small fx. Okay, fx is the function of which integral is to be calculated. Fx is the function which is the derivative. This is the derivative of fx, and fx is the function which is the integral of small fx. This is the integral of the small fx. Okay, so this is how we define it. Integral, this is differentiation of fx if is equal to fx, then integration of fx is equal to fx. Okay, integration of fx with respect to here with respect to x. How do we detach integral of fx? Now what is the general process of this? So let me This is proper definition of this. Okay. Now let me discuss about what is a constant then. Then what is a constant? Constant of integration. Let me discuss about this. What is the constant of integration? That is the third topic here we have to discuss about. What is the constant of integration? So constant of integration. What is the constant of integration? Let me discuss about this. Okay, here as we have defined, as we have come to know about, we have come to know about that fx, capital Fx, is the integral of small fx. So also the fx plus constant c. How? This is also the integral of fx. How? Let me define it. Since we know that ddx of fx, okay, this is, let me write here like this, is equal to ddx of fx is given to us as fx. Also, we know that ddx of fx plus constant c. If I write here constant c, this is also equal to fx. Okay, because constant, definition of constant is 0. So definition of fx here is fx. So fx plus c and fx both are the integral of fx. This implies that what do we get from this? The integration of fx into dx is equal to fx. Also integration of fx is equal to integration of fx into dx is also equal to fx plus c from this second. This is first and this is, let me take second. So from first and second, what do we get? That integration of this fx is equal to fx, integration of this fx is equal to fx plus c. Why? Because differentiation of this is the same thing fx, because constant differentiation is 0, so no change here. So differentiation of these two is the same. Integration of these two will be different. So it is said that the integral of the same function, okay, may be differ by a constant. Okay, in two ways, it will be the integral of a same function may differ by a constant. The integral of a constant may differ by a of a function may differ by a constant. In this case, this is integral fx. Here integral is fx plus c. Where difference here constant fx plus c minus fx and plot. See the difference. Difference of integral of the same function may differ by a constant. Okay. In two methods we have taken, the constant is the difference of the same function's integral. Integral of the same function may differ by a constant, it is said. So this is how the constant of integration will be written. So we can just say, let me take numerical examples or illustrative examples here, so that it can be very much clear. So now we see that ddx of, we know that ddx of, okay, let me take x cube, okay, x cube, ddx of x cube equal to ddx of x cube plus, let me take 2 here, equal to ddx of x cube minus 4, okay, equal to ddx of x cube, okay, plus c, constant, equal to d dx of x cube plus 4 into c, a constant. I mean, a number of constants are here, but they have the similar value, that means 3x square only. The answer is differentiation of all these functions is equal to 3x square. That means what? That integration of 3x square. Therefore, this implies that integration of 3x square into dx is equal to, we see here, this is x cube or x cube plus 2 or x cube minus 4 or x cube, this is plus c, or x cube plus 4 into constant c. Integration of the same function is differ by is having infinite values. So here constant is a different constant can be taken. So constant is an addition to this. But in case of, for the sake of convenience, we sometimes we will omit this constant, writing constant, because we always write that integration of sin x or into dx is equal to this sin x equal to cos x. Integration of sin x into dx is equal to cos x. This is because we know that cos x, differentiation of cos x is minus sin x, minus cos x. Because we know that the ddx of cos x is equal to minus sin x. Differentiation of minus sin x. So therefore integration of sin x is equal to minus cos x here. So similarly integration of cos x here into dx equal to sin x. Why? Because differentiation of sin x is cos x. But so integration of cos x is plus sin x, but integration of sin x is minus cos x, because differentiation of cos x is minus sin x. You know that it will be negative sign. Sin x integration is minus cos x. So we write without constant here. Constant is not repeat more, is omitted, but we understand that this is indefinite integral. In case of defining indefinite integral, this is because that is known as indefinite integral. Why? Because the values are not definite. The answers are not definite here. For the same integral values, it is minus cos x. We can write constant here, sin x plus c constant. It will be equal to, even then it will be equal to minus cos x, minus sin x. Sorry, it will be, if I write here plus constant c, plus constant c here. If I write here plus 2, plus 3, if I write here, differentiation of all these functions will be this one. So these two will have the same value. For ddx of this is sin x of this is equal to this. So minus sin x cos x, I'm writing here. So integration of the sin x equal to cos x minus cos x plus c, or we can write simply cos x. For integration of sin x into dx equal to simply cos x minus cos x. Without any constant here. So constant may be written or may not be, but we understand this is indefinite integral. Constant is there. It is just obvious that constant is there. This is to be understood that constant will be there, because the integration of the same function in two methods may be differ by a constant, the same function. So this is how a constant is known as constant of integration. So this sometimes it is omitted, but it is understood that there is a constant there. So we omit just for the sake of convenience. We mostly write the integration of this and this equal to this. So we always constant of integration we have defined here. Now let's talk about constant of integration. What the general process of integration there. The general process of integration, let me define. Take this. General process of integration. And what is the general process? General process of integration. What is general process of integration? We use the symbol used for integration for integration is, let me write here x into dx. Here x may be replaced by another variable. It may be d u s theta phi whatever, okay, zeta any or let me take etc. It may be because here this sign depends upon, I mean, the process of integration is noted by this, that we are integrating with respect to x here or any other etc. Let me write here etc. Here dx denotes okay with respect to which the integration is being done. Okay, the integration is being done. That means we are integrating with respect to x here. This dx denotes the variable with respect to which we are integrating. Here it may be t, dt, it may be ds, s, different than respect to here. The function may be any other, but here this variable dx, I mean this d into x, or sorry, this is dx only symbol. Dx and this symbol, they are taken together. Okay, without, I mean this symbol and dx, they cannot be separated. Dx and symbol, I mean dx may be replaced by phi, etc. But this symbol and these two are together. Okay, in between there is a function. Now we cannot say that dx is written before the function. We cannot write dx into x. We cannot write dx into sin x. No, we write first the function, then this dx symbol is written later. Okay, this is the combination of this. Okay, so the with respect to denotes the variable with respect to which this is the variable. This is the variable here. Here the dx denotes the variable with which here x means the symbol to for integration. This denotes the integration is being done with respect to x. Here it may be ds, then with respect to s, maybe dt with respect to t. Then so this is the symbol we use here. Okay, s as I've already introduced. Here the symbol is s is the elongated s. Okay, this is elongated s, which is the first letter of sum s. With the letter of sum, this word sum. Okay, so s is the first letter of sum. This s of sum, because initially the integral calculus was aimed to find out the sum of areas of small elements of a plane which was divided into these elements. Okay, it was divided into a plane which was divided into these, which were divided into these elements, which were divided into these elements. Alright, now initially it was, so integration is also used just to find out, not only having, the sum of the area of the plane, okay, which is bounded by plane curves, is not only limited to that. You will also use in integral calculus to find out the length of a curve, length of a plane curve, then the area of a surface, then volume, okay, then center of gravity even, and moment of inertia as well. Okay, so all these fields are also having implication of this or application of integration. Integration is also used to find out length of the curve, okay, area or area of surfaces we have to find out. Then the volume also of a cuboid, etc. we have to find out. So volume, surfaces, areas, as well as moment of inertia, center of gravity, etc. These are also having application field of integral calculus. Integral calculus is also used to find out the area of all these things, the volumes of solid figures. That we will discuss later, but still it is. So let me write here plane which was divided into these elements. Okay, let me write here the field of the application. Let me write here the application of integral calculus. The application of integral calculus is also found to find the length of a curve, length of a plane curve, surfaces means areas of surfaces, volumes also we find out, volumes, center of gravity, okay, moment of inertia, this is moment of inertia, etc. Moment of inertia, this we will discuss in later periods, later lectures. So that is how we discuss about. So this is the benefit of this. So this symbol, this one is used here. Symbol, this is just elongated S here. This symbol is used, and dx and let me write here. This dx and s, they have no meaning independently. They have combined meaning for integral calculus. Okay. Here, the symbols, this one and dx have no independent meanings of them. No independent meanings of them, but they are used combinedly. Okay, in combined form, they are used in combinedly. Let me write here. Okay, and also we cannot write, and also we cannot write as, okay, there's symbol this, then there is a function fx here, okay, and the dx we have written here. This is wrong, cannot be equal, but it should be written as this into fx first, then dx. This is the proper one. This is improper. We cannot write dx before the function. Function is written first, after this symbol elongated as, after that function, then this. Okay, function is in between symbol, this symbol s and dx. Okay. Function is like that here. So function is, or function comes in between the symbol and the dx. Okay, dx cannot precede the function fx. Fx precedes dx. Okay, this precedes all. This precedes function. Function precedes dx. Dx is the in the end. Okay, so this is how the symbol is elongated. This is generally process of integration. We differentiate a function with respect to dx. It shows that what variable is to be used for differentiation, with which variable we are integrating. This is integration process. We have to integrate with respect to the variable given here. This is the general process of integration. We write these symbols in this process. Okay, this is how. Now let me talk about constant we have discussed over. Now, okay, the next thing is that how to find out integration of the product of a constant and a function. The integration of a constant and a function. Let me find out the fourth one. Integration of a product of a constant and a function. Okay. Integration of a product of a constant and a function. Let me discuss about this. Okay. Now we know that ddx of, here let me write a into fx is equal to, let me take this is equal to a into fx. A is constant in multiplication. Okay. Therefore, this implies that integration of a into fx, okay, a into, let me write here, a into fx, this one, into dx, this dx is taken to that, equal to a into f into x. That means the integration of a constant into the product of a constant and a function is just equal to the constant into the integration of that function. Okay. We can write it as, or we could take this as this one, or symbolically we could write that ddx of fx. To write this also like that. This is a equal a into fx here. Again, a into integration of this is, for differentiation of this is fx here. Therefore, integration of a into this fx, it can be taken out of the sign of integration into fx into dx is equal to fx, a into fx here. Okay, so integration of this, a constant, so constant is to be multiplied with the integration of the function. The integration of the function, okay, so integration of the function given and product of the constant is equal to the constant into the integration of the function. If the constant is multiplied separately, its integration is not given, but it's just in the multiplication of the constant. So constant and product of the constant. Now let me talk about what is the integration of sum or difference of two functions or more than two functions. Let me talk about next method. So now integration of a sum or difference of two or more than two functions, or more than two functions. Initially we take two functions only. That let me discuss about. Now we know that differentiation of ddx, let me write here. We know that ddx of, let me write here, this is capital F1x, okay, plus minus, let me write plus and minus both, into f2x is equal to how much? It is just given to us ddx of f1x plus minus ddx of f2x. This is what we have now. This is equal to, now we know the ddx of f1x is equal to this one. Let me write here. And ddx of f1x equal to small f1x, while ddx of f2x equal to f2x let. Okay, this is given to us. These are the differentiation of these functions. Therefore, differentiation of these two different functions will be how much? So it will be, therefore, from the first one, let me take first. Okay, therefore, the ddx of this one f1 x plus minus f2x will be equal to f1x plus minus f2x. Therefore, integration of f1x plus minus f2x plus minus f2x into dx equal to capital F1x plus minus f2x. So what is this? That integration of the sum or product of two functions is equal to the integral of the sum of the integrals of them. Okay, the sum or difference of the integrals of the two functions here. F1x is the integral of f1x, okay, and f2x is the integral of f2x. Therefore, the sum or difference of this one or integrals of two functions is equal to sum or difference of their integrals. So these are the integrals. Now it is known as integrands. Okay, these are known as integrands here. What are the integrands? F1x and f2x are known as integrands. But the integrals of these two functions are the integrands here are f1x and f2x. They are known as integrands. Integrands are, we can say, the sum or difference of their integrals. The integration of two or more than two functions, sum or difference of two or more than two functions is equal to the sum or difference of their integrands. Okay, this is f1x plus f2x. This is how, and this can be applied for more than two values. This can be applied for more than two functions or more than two functions as well. More than two functions as well. Okay, so if I write here, let me take ddx of, okay, this is capital F1x plus minus f2x plus minus f3x plus minus f3x plus minus and so on. Finite terms, there are finite terms f and x. Okay, these are the integrals here. F1x plus minus, they are differentiation. F2x, if I have taken them like this, f2x plus f3x, okay, plus this is plus minus and so on. And the last step is f and x. Therefore, integrations of all these functions will be equal to these. Okay, so therefore, integrations of f1x plus minus f2x, okay, plus minus f3x plus minus and so on, plus minus f and x, okay, into dx is equal to into dx here, okay, is equal to the sum of them. This is f1x plus minus f2x, okay, plus minus f3x plus minus and so on. This is last one, plus minus f and x. Okay, so this is how it can be applied for more than two variables, two functions as well. This is how the process of integration we have just defined here. Okay. Now, as we have discussed about that integration is the antiderivative or is the just reverse inverse of differentiation. Okay, so we will discuss about these questions here. Then, and before, after completing this lecture here, then I'll discuss about in the next lecture, maybe in the next lecture, I'll note down some important formulae, okay, of integration versus the differentiation. Okay, how differentiation it is. Similarly, integration can be obtained. So integration and differentiation both are, if formulae of them are written simultaneously, then they can be remembered by the by the students or by the people who are studying this subject. So that will be very helpful. In the next lecture, maybe in the second or third lecture, I'll discuss about those formulae. Whatever formulae we have used mostly in differentiation, they will be written in comparison integrals of them. Okay, the formulae for integration as well. Is that all right in the next lecture? But before that, let me solve these questions based on summation, sum or difference of two or more than two functions. This process I've talked about. And integration is the antiderivative or just reverse of this. Before that, we have discussed that it was initially meant for summation of areas, okay, or finding the different elements which were divided, which were obtained by division of the plane area into different elements. And after that, there sum of all those areas of elements were found out, and then as a limit of some general method was found that how to find out area of the whole plane after dividing them into the plane areas. That was mentioned. Whatever I've discussed here is the beginning of integral calculus, how integral calculus was discovered. Okay, and that I've just talked about the process of this, the general method, the process of integration, how the process of integration is written down. Here I am taking these questions now on down, where you would be following integrals. Now let me discuss these functions here. Question number 1. This is very important here. So first question is sine of integration 3 into cos x into dx. Okay, this we have to discuss. Now this we know that ddx of sin x equal to cos x. And if I write, so ddx of a constant here is given 3 into sin x equal to 3 into cos x. Because the constant here multiplied with this, and in differentiation of this is cos x, sin x is cos x. Therefore, integration of 3 cos x equal to 3 sin x. Therefore, this is equal to, integration of 3 into cos x into dx is equal to 3 into sin x, 3 into sin x. Yeah. 3 sin x plus constant of integration we can write here, but it is not required, but we write. Okay. Or it is just understood that constant is there, but it is indefinite integer. We are defining it as indefinite integer here. We know that differentiation of this 3 sin x is 3 into differentiation of sin x is cos x, positive. Cos x differentiation is positive sin x. Okay, so integration of cos x is positive sin x here. Okay, so 3 sin x, this is the answer here. This is the first question we have solved. Next question, the second one. Okay, the second question here, sine of integration 1 minus x under root x into dx. What do we do? This is by the sum method. Let me write here. Integration of this 1, that means under root x, we have to multiply this under root x to 1 minus x raised over 3 by 2. Why 3 by 2? Because this is 3 by 2. Okay. Now, before that, let me talk about integration of x raised power n. How x raised power n is integrated. That defined, and after that we will discuss about this. So here I have multiplied 1 minus x to under root x. Under root x into 1 is under root x, or x raised power half. This is x raised power 1 and x raised power half means 1 and half, that means 3 by 2. This I have written here. Let me discuss what is Differentiation, we know that. What is differentiation? We know that, let me write here. We know that ddx of x raised power n plus 1, okay, divided by n plus 1 is equal to what? This we know that this will be n plus 1, x raised power now n, because 1 power is less than n plus 1 minus 1. That means minus 1 and plus 1 cancel out. Only n will left over. Okay, divided by n plus 1. This is what? N plus 1 is cancelled out. This means x raised power n. So what is integration of x n? Therefore, is simple as that. Integration of x raised power n into dx is equal to x raised power n plus 1 on n plus 1. This is how we have to find out what is integration of this. Okay, so integration of x raised power n is what we do? We add the index, the power or index of the polynomial given here. Here it is x raised power n, and initially it was given. So we add 1 in the index and then divide the same function by that obtained index. Now change the index is to be written in the denominator. Okay? Or we divide that function on obtaining this index, then divide that index by n plus 1 by the now obtained index. Whatever index we have obtained now, we will divide the whole function by that. So n plus 1 is to be written in the denominator. Now we divide the whole function of this index after adding 1 in the index. After adding 1 here in this index, we divide the function by n plus 1 then. Okay, by the obtained index. Here it is n plus 1. Okay, this is how we have to differentiate. So what we do? In case of integration, we add 1 in the index and we divide the obtained result by the obtained index. Okay, so obtained index, whatever n plus 1 here we have obtained, we divide that. This is how integration of a function, polynomial function xn is given. Okay, now let me define that. What is integration of 1 upon x? Integration of 1 upon x is what? Now we know that. We know that this is our integration of x raised power minus 1 into dx. Now we know that differentiation of log x to the base e is equal to 1 upon x. Therefore, integration of 1 upon x is equal to log of dx. This is equal to log of dx, log of x to the base e. So integration of 1 upon x is log of dx, because we know that differentiation of log of dx is 1 upon x. Therefore, integration of 1 upon x is log of dx. These are two functions which we have to know about. Now in this case, we have to integrate these functions writing by separately. This is integration of x raised power half here into dx. Let me write them separately with different sign in between. This is x raised power 3 by 2. Still I have not integrated, writing them separately. Now integrate. What do we do? As we did here, x raised power n equal to x n plus 1 upon n plus 1. In the same way, what we do? X raised power 1.2 plus 1 divided by 1 plus 1.2 plus 1 minus sign. Similarly here, x raised power 3 by 2 plus 1 divided by 3 by 2 plus 1. This is the answer. Plus constant we can write. We are omitting constant here because this indefinite integral. Constant is understood. Constant is there because the difference of integral of the same function is differ by constant. Okay, that we know. So constant we are not writing, simply by writing the result. Here it is 3 by 2, the denominator. Numerator also the power is 3 by 2. I'm sorry, this is 3 by 2 divided by 3 by 2 means 2 by 3. Take 3 by 2 in the numerator. So 2 by 3 into this. Sorry, this minus sign in between. Minus sign. This is 5 by 2. 3 plus 2, 5 by 2. 2 by 5. This is 2 by 5 into absolute power 5 by 2. Okay, this is how we have to find out these values. So this is the answer of this question. This is the second question. Okay, second question we have done here. Now let me take the third one. These questions are just noted down from the students' queries. We saw lot of questions were there. I've taken only selected one for the beginning, for the beginners only, that I've taken here. Now let me take the question number third. The question third says that, okay, integration of or integral of x square plus 8 whole square divided by x4, right, into dx. This is integral of this. What do we find out? First, let me open the square. What we do, we just open the square of this. This will be x4 plus, because a square plus b square plus twice ab. This is x square plus twice into 8 means 16 into x square plus this square means 64, 8 square divided by x4. Okay, so we can write, after dividing each term or each function, each term here by x4, what we get, this is x4 upon x4 means 1, that means 1 into dx only, plus this is 16 upon this means 16 into x raised power minus 2. I've taken this minus 2 power in the numerator. Okay, so this x2 will come in the denominator, but I've taken that in the numerator, so this will be power minus 2. Okay, plus this is 64. Let me write it before the sign of integration, and this is x raised power minus 4 into dx. Now we can integrate this by the formula. Here, what is integration? Let me write it as 1 means x raised power 0 here, okay, into dx. This is 16 into x raised power minus 2 into dx. Plus this is 64. Still I have not integrated. Now let me follow the process. 1 is x raised power 0. Any power 0 is 1. X raised power 0 is 1. 2 raised power 0 is 1. Okay, so this R1 are written like this. Now, what is integration of this? If I follow the polynomial rule, just write x raised power n. It will be x raised power 0 plus 1 upon 1 only. Okay, this is plus 16. X raised power minus 2 plus 1 upon minus 2 plus 1 plus 64. X raised power minus 4 plus 1 upon minus 4 plus 1. So this will give us only x here, because x raised power 1 is x, plus okay, it will be minus 1 in the denominator, it will be negative sign. Let me write here minus sign here. This is minus sign. 16 into this x raised power minus 1, that means 1 upon x. 16 upon x here. Okay, this is minus sign again, minus 3. So this is 64 upon 3. 1 upon x raised power 3 positive. So x raised power 3 has come in the denominator. Or people write x raised power minus 3 or power. This is the difference. Minus 4 plus 1 is minus 3 power. X raised power minus 3 means 1 upon x3. We are taking, this is minus 3, that I have taken here minus sign. Okay, so this is unknown. So let me write further. This is x 60 minus 16 upon x minus 64 upon 3 into x cube. Okay, so this is the answer here. Question number third, okay, is solved. This is question number third answer. Okay, now let me take the question number fourth. So the question number fourth is the sum or difference of two or more than two functions here defined, which I have already clarified that how we have to find the integral of sum or difference of two or more than two functions. Let me take the fourth question here. Now question fourth is having some parts 1, 2. Okay, the first part is what is 0 into df. Integral of 0 is what? Yes, we know that 0 into something is 0, but it is only constant equal. So 0 into something is 0, but integration of anything is the integral of that value plus constant, which will be 0 plus constant. It is only constant. So constant is your first part. First part of this. What is second part? Integral of x raised power 9 dx into dx. So it will be given by simple x raised power 99 plus 1. 199 plus 1. Now we will just write directly. This is x raised power 100 divided by 100. Only answer This is plus constant we can write, no problem, it is constant of integration. Or just for the sake of convenience, we just write directly value, but constant is understood here. Okay, so that may be repeated, may not be repeated, but we can write this there. In case of this, there was nothing of it, but constant by there, so it is differ by constant. So 0 into something is 0. This is the two parts of question number 4. Now let me talk about question number 5th one. 5th one is also having two parts here. This is question number 5th. First part says, this is the actual power sine of integration actual power minus 8 into dx. Again, integration we know that since xn is actual power n plus 1 upon n plus 1. Similarly, this is actual power minus 8 plus 1 upon minus 8 plus 1. Just integration. This is actual power minus 7 upon minus 7 is equal to minus 1 upon 7 positive. This is power is positive, okay, but minus 1 upon 7 into actual power 7. This is the answer of this question. So this is the answer. First part. For the second part here, just by rule of polynomial actual power n, we are applying here. Here also, this is sine of integration actual power minus 102 into dx. We can just integrate this by the same formula of polynomial function actual power n. This will be actual power minus 102 plus 1 upon minus 102 plus 1. That means minus 1 upon, I will take this 101 in the denominator. It will be 1 upon 101 into actual power 101. This is 101 multiplication, numerical value. 101 into actual power 101. This is the answer here. Both parts are solved of question number 5th. Okay, this is question number 5th here. Yes, done. Simple questions, because this is a process of integration. I am taking bit by bit so that the students can understand clearly that what the concept of integral calculus. Okay, I'll note down the formulae as well, but that I'll take in the second or third lecture, because most of the formulae which are found out just antiderivative. So differential calculus we understand, we have just talked about that. Okay, or we know about that the formula of differential calculus, one is knowing that integration is very easier for them. Okay, so the formula for both subjects, integration and differentiation, must be known to the students. Only then they can get mastery over the subject. So let me take the 6th question here. So 6th question is also having two parts. Now, question number 6, first part is sine of integration actually for 1.3 into dx. So again, using the polynomial formula, this is equal to actually for 1.3 plus 1 upon 1.3 plus 1. That means actually power 4 by 3. Okay, 1 plus 3 upon 3 divided by 4 by 3. That means 3 upon 4. Actually power 4 by 3. Positive. This is the answer here. What is the second part? Now second part is x. Okay, this is sine of integration x square into under root x into dx. Now we have to multiply them both. This is actually power 2 into actually power half power. Now when bases of same powers are added into dx, this is equal to sine of integration actually power 2 plus half into dx. Now we have to make them 1. These two functions multiplied, but they are similar bases. Powers are added here. The final function for integration is actual power 2 to the 4 plus 1 5. 5 by 2, this is 2.5 into dx. Therefore now integration process starts. This will be actually for 5 by 2 plus 1 power divided by 5 by 2 plus 1. That means 5 plus 2 is 7 by 2. We actually for 7 by 2, and this is 2 by 7 here. We actually for 7 by 2. Okay, so this is what we are working. Here 3 by 4. So that is answer. So here also 2 by 7. Because here it will be 7 by 2, 2 will come in the numerator. This is the answer here. The two parts of question number 6 are also solved. Okay, now let me take the 7th question. Number of questions are here, but they are okay. clarifying doubts regarding the integration, integral calculus or integration of functions, initial functions. What are them? Okay, integration of initial functions here. Now let me talk about seventh question here. Okay, so seventh question is, it is integration of actually 4 minus 3 by 2 into dx. Simple. Here only minus sign is there. It will be simply integrated as minus 3 by 2 plus 1 divided by minus 3 by 2. The index is taken in the denominator as well after changing or adding 1. After adding 1 in the index, okay, we divide by the same index after adding 1 to the same function. So this is the value of it. This is minus 3 plus 2, that means minus 1.2. Actually for minus 1.2 in the numerator divided by minus 1.2. That means minus 2 upon x half power or square root. That means minus half power we have taken the denominator. It is the square root of x here. Minus 2 upon x raised power half or 1 2. This is the answer final. Minus 2 upon this negative sign. Minus 2 will come in the numerator. So minus 2 upon under x. This is the answer here for the seventh question we have done. Now let me take the question number 8. What is the question 8 says? This is says that the sine of integration 2 upon 5 into x raised power x raised power minus 5 by 2 into dx and in multiplied by 2 by 5. What is integration of this? Now we know that this is 2 upon 5 constant is multiplied to the integration of this function. Let me write it there. X raised power minus 5 by 2 into dx. Now let me integrate that. This is 2 upon 5 constant multiplied to the function given, that means minus 5 by 2 plus 1 divided by minus 5 by 2 plus the final answer will be 2.5 into it will be minus 5 plus 1 means minus 3 by 2. It will be minus sign. Okay, let me first write it as x raised power minus 3 by 2 in the numerator, not be minus 3 by 2 in the denominator also. Okay, so this is minus 5 plus 2, that minus 3 by 2. Minus 3 by 2 will also be the power here. So final answer is, this is minus 2 to the 4, this is minus 4 by 5 say 15, okay, negative sign, into x or into 1 upon x raised power 3 by 2. This is nothing but minus 4 upon 15 into x raised power 3 by 2. This is the final answer. Minus 4 upon 15 into x raised power 3 by 2. This is the answer here. Okay, so this is question number 8 here. Now question number 9th, what the question number 9 says. Now if I take differentiation then integration, we know that how differentiation is to be calculated. Integration is a just antiderivative or is a inverse of differentiation. So now 9th question is having 2 parts. Let me take the 9th question. First part is sine of integration. This is twice x plus 3x square into dx. Now this can be written separately, okay, because sum or difference we know this is plus sign sine of integration 3 into x square into dx. Further it can be written as 2 into x into dx plus 3 into x square into dx. Now it can be integrated 2 into x power 1. This is 1 already, it will be x square because 1 plus 1 upon 1 plus 1, the denominator. It will be 3 into x raised power 2 plus 1 upon 2 plus 1. It will be 2 to cancel out. This is x square plus 3 cancel out. This is 2 plus 1 is 3. 3 into, so 3 is 3 cancel out. This is x to 1 here. Final answer is, this is the answer here. Okay. Simple integration process we follow. Now if I write differentiation simultaneously with integration, that it can also be done. We know that differentiation of this is equal to this, therefore integration of that will be this. This is the process that are already defined and written. Elongated thing of that thing will not be used here. Okay. So let me take the marker here. Now question number 10, sorry, second part of this one. Ninth question, second part. This is 4x plus 7 upon x into dx. So, okay, this is 4x plus 7 upon x into dx. So this can be written as, writing separately, this is 4x upon x plus, let me write here, sorry, separating them after dividing. This is sum of integration 7 upon x into dx. 4, okay, so this x is cancelled out. This is 4 into dx plus 7 into 1 upon x into dx. 1 upon x into dx. Alright, so this is what we have. 4 into x. So 4 can be taken separately. 4, this is 1 into 1 is integration is x. That is x. 7 into this is log of ex, we know. Since I've already defined it, since differentiation of log of ex, okay, log of ex is equal to 1 upon x. Therefore, integration of 1 upon x into dx, 1 upon x into dx is equal to log of ex. Log of x to the base e. Log of x to the base e. Base is e here, no problem. This is 4x. 4 into x. 1 integration is x. Because 1 can be written as x raised to 0. X raised to 0 means 0 plus 1 upon 0 plus 1. That means x raised to 1 means x only upon 1. Okay, so x only. 1 integration of 1 is x. Now, because in this case we are differentiating, sorry, integrating with respect to x. If it is with respect to t, then integration of 1 will be t. If it is integration with respect to s, integration of 1 will be s. So that is the independent variable, whatever we are using, that value will be converted as 1. Integration of 1 will be that integration variable. Okay, so that is independent variable. So this is the answer of question number, second part of 9th. So the 9th question is done. Now let me talk about next question. This is 10th one. Okay, so question number 10th now. It says that integration of, question number 10, integration of, there is sum of number of functions, 1 plus 2x plus 3x squared plus 4x cubed into dx. Okay, so this is, can be written as differently, we can write them as separately. So 1 into dx plus 2 into x into dx, plus let me write 3 away from this is x squared into dx, plus 4 into x cubed into dx. Here 1 integration is x only, this is x, plus 2 into x power 1 was there, was 1 plus 1, that means 2 upon 2, okay, into plus 3 into x raised to 2 plus 1 upon 2 plus 1, plus 4 into x raised to 3 plus 1 upon 3 plus 1, can be written as constant of integration there, that is understood. 2 cancelled out, this is plus x squared, 3 cancelled out, this is 2 plus 1, 3 cancelled out, x raised to 3 only, 4 cancelled out, 3 plus 1 is 4 here, this is x raised to 4 only, this is the answer. Question number 10 is having single part. Okay, so this is how we have to indicate this. 11th question now. Let me take the question number 11. What does the 11th question say now? That question number 11, let me talk about. Okay, so this is sum of integration ax square, ax cubed, okay. This is plus b, bx square, plus cx plus d constants. We are multiplying each polynomial function, algebraic function, by constants. That constants are there, no problem. Now separating them, writing integration sign. This is a constant, sign of integration with x cubed into bx. This is b constant taken out of the integration sign, no problem. X square into dx plus c out of sign of integration x into dx plus d only. This is 1 into dx only dx can be written no 1. Okay, so this is how, this is a into x raised to power 3 plus 1 on 3 plus 1 plus b into x raised to power 2 plus 1 on 2 plus 1 c into x raised to power 1 plus 1 on 1 plus 1 plus d into x and d. This is x and d. So 1 is x raised to power 0, that means the integration of 1 is x. Okay, so let me further write it as a upon 4 into x raised to power 4 b upon 3 x power 3 plus c upon 2 into x raised to power 2 plus d into. So this is the answer here. This is the answer of question number 11 here. Okay. Question 11 is solved. This is how question 11 is solved here. Just integrate, put the integral sign on sign of summation. I mean, after the sign of summation. So sum or difference of two or more than two functions is integrated separately, and then their sum is found out. That is how we have to integrate the functions. Now 11th we have done. Now 12th question, let me write here. The question number 12 is integration of under root x is in bracket, it is okay 3x square plus 2 into dx. Okay, so in this case we have to multiply. It can be written as 3 constant can be taken out of the sign of integration. This is x raised to power half into x raised to power 2 into dx. But 2 is the constant sign of integration. This is under root x into dx. We are multiplying by under root x2, 3x square into 2 plus 2. Okay, so plus 2 into under root x, that means under root x can be taken inside. Because x is the variable with which we are differentiating or integrating. And this is sign of integration. Okay, so sign of integration this and x, the variable with which we are integrating. So this is how we integrate. Now these two powers are added. Why the same powers are added? We have to add these powers here. This is 2 plus half, that means 5 by 2 to the 4 plus 1 5 into dx. Then it will be integrated. This is actually for half power into dx. And let me integrate this. Actually for 5 by 2 plus 1 upon 5 by 2 plus 1 plus 2 into x raised to power 1.2 plus 1 upon 1.2 plus 1. Okay, constant of integration we are not writing again and again. That is just for convenience, sake of convenience. But we can write that no, that not a mistake. We can write here constant of integration plus constant of integration. We can write, but there is no need of this because we are just understanding that constant is there. It is indefinite integral. Indefinite integral is having a constant. You understood? But it's not definite. The integral of the same function is not unique. Is not unique. I mean, it's not one single. It can have a number of variations of that. Okay, it can have different constants. Either it is c constant, then d constant. Any constant you write, the value may be different. The value of integration is infinite. That because of that is known as indefinite integral. Okay, so indefinite integral we are discussing about. Value will be different. Now this is 5 plus 2, 7 by 2. 2 will come in the numerator, so this is 6 by 7 into x raised power 7 by 2. Now this is 3 by 2 here. 2 will come here, this is 4 by 3. 2 into 2. 4 by 3, x raised power 3 by 2. Plus constant c, no need of this. We can write it. Okay. This is the answer here. The question, this is 12th question we have done. Question 12 is solved. Let me talk about 11, 13 questions. Question number 13 says sign of integration. We will value them. This is a upon x square plus b upon x plus c into dx. Okay, no problem. So let me write them separately. This is a constant 1 upon x square into dx plus b upon x. This is b given by 1 upon x into dx plus c constant of integration into dx. Now let me write it again. This is x raised to power minus 2 into dx. But this is b into log of integration of 1 upon x, log of x to the base e plus constant c into 1 integration is x, c into x. Plus this is a into x raised to power minus 2 plus 1 minus 2 plus 1 denominator is b into log of x to the base e plus c into x. Now we can write it as minus 1 only. This is minus a upon x, because x will come in the denominator as positive. Minus 2 plus 1 is minus 1. X raised to power minus 1 is 1 upon x. This is plus b into log of x to the base e plus c into x. Final answer. Okay, so this is value of question number 30. Now let me take 14th question. Question number 14, what does it say? It says this one, okay. Let me write them. They are just addition of polynomial function. This is 14th question. This is sign of integration 3 under root x. Okay, this is plus sign 3 upon x4 into dx. Sorry. 14th we are discussing about, okay, 3 upon, alright, this is 3 under root x. 3 under root x plus 3 upon x. Alright, this is the same question. Question number 14. Now let me write the constant out of the sign of integration. This is under root x means x raised to power half plus 3 can also be taken as x raised to power minus 4 can be written in the denominator. Okay, this x raised to power 4 can be taken in the denominator as negative power. So this is 3 into integration of x raised to power, sorry, this is dx. Dx we always write with each term, okay, each function. So this is x into x raised to power half plus 1 on half plus 1 divided by 3 x raised to power minus 4 plus 1 on minus 4 plus 1 3 here. Okay, so let me further solve it. This is 3 into x raised to power 3 by 2. The denominator we will have 3 upon 2. That means 2 will come in the middle. This 3 we cancel out. 3 upon 2, 2 will come in the numerator. Plus, this is the minus 3 in the denominator. This is 3 into x raised to power minus 3 upon 3. This we cancel out. While negative, because minus 3 plus 1 is minus 3. So minus sign are taken here. Plus minus is minus. Okay, now this is 2 into x raised to power 3 by 2 positive. This is minus sign 1 upon x raised to power 3 positive. So this is the answer here. Okay, so answer of question number 14th. This is the question 14th. And let me take 15th question. Question number 15th. We have 27 questions here. Very important question. There are 4 more questions here. Question number 15th, let me talk about. Question number 15th. Sign of integration. It says 2 into x raised to power 3 3 into x minus 7 into, out of this x raised to power minus 2 by 3 minus 2 by 3 into dx. Okay, so this is question number 15 here. Twice x cubed plus 3x minus 7 into x raised to power minus 2 by 3 into dx. Okay, now let me multiply each term or each part of this whole function by x raised to power minus 2 by 3. So it will be twice into sign of integration x raised to power 3 into x raised to power minus 2 by 3. Okay. Plus 3, let me take constant out. So x into x raised to power minus 2 by 3. Still I have not added them. This is minus 7 sign of integration x raised to power minus 2 by 3 dx. This is also dx. I'm sorry, this is also dx. Dx must be written so that we can understand that what we are integrating with respect to what. So this is twice into x raised to power minus 2 by 3 plus 3. That means 3 is 9 minus 2 7 by 3. Power is 7 by 3. Why? Because 3 minus 2 by 3. 3 is 9, 9 minus 2 means 7 by 3. Okay. Plus 3 into 1 minus 3 by 2 by 3. Sorry. It is 1 by 3 only, positive. X raised to power 1 by 3. Why? But if I add 1 minus 2 by 3, LCM is 3, will be 3 LCM. 3 minus 2, it is 1 upon 3 here. That's why I have written here over. Yes, this is dx. Minus 7, this is single minus 2 by 3. Now let me integrate them. So separate integration of each term. Okay, each part of this will be y into x raised to 7 by 3 plus 1 divided by 7 by 3 plus 1 plus 3 into x raised to 1.3 plus 1 upon 1.3 plus 1 formula for x raised to n. Okay, that is x raised to n plus 1 upon n plus 1. That's the same formula. Minus 7 x raised to minus 2 by 3 plus 1 upon minus 2 by 3 plus 1. Final answer. Constant of integration can be written, may not be written. Just check for convenience. I'm not writing it again and again, but that is understood here because it's indefinite integral. Constant is understood there. Okay, that I'm not writing again. Okay, so this 7 plus 3, 10, 10 by 3 with 3 to the 6, 2 into 3 upon 10 in the denominator. Actually, over 10 by 3 plus this is 3 plus 1 4 by 3. 3 will come in the numerator upon 4. 3 into 3 is 3 in the denominator will come in the numerator. And actually power 4 by 3. Okay, minus 7 and this minus sign is okay, this positive sign. So it will be x raised power 1.3 positive. Minus 2 plus 1 plus 3 that is plus 1.3. And divided by 1.3 positive, it will be 3 into 3. Okay, this will be 2 5 yeah, it will be 3 by 5. Always simplify the fractions. Least fraction we have to write. Plus this is 3 9 by 4. Then we cancel out. Actually 4 by 3. Minus 7 3 at 21. 21 actually 4 1.3. Final answer here. Okay, so powers of x are 10 by 3, 4 by 3 and 1 by 3. And multiplication by constants 3 by 5, 9 by 4 and minus 21. So this is the answer of question number 15. Question number 15 we have done. Now let me talk about question number 16. What is question 16 say? Okay, so question number 16. What does it say? 16 is this one. This is with respect to another constant here, constant of variable. Here variable we have taken as k or s can be taken as. Okay, let me write it as question number 16. Let me write it as constant I have taken. K is mostly taken as constant. Let me write here s. This is s and this is with respect to s ds here. We can write like this. This is 16th question. Kind of integration. Let me write it as 3 into s minus 4 minus 4. Is it whole square? Oh yes, it's whole square. Whole square into ds. First of all, we have to open the whole square of this. What the whole square of 3s minus 4 whole square. Okay, so 3s minus 4 whole square. Let me open the whole square. This is 9s square plus sign, or let me take minus sign in between. Middle term. 3 4 is 12, 24. 4 3 is 12, 12 2 is 24, 24s. This is s here. Minus 16, sorry, plus 16 here. 4 square. A square plus b square minus 2ab. Okay, this is the formula. Into ds. Now let me separate each term. This is 9 sign of integration s square into ds. And 24 sign of integration s into ds. Sorry, this is ds. Okay, plus 16 constant sign of integration into ds. Now again 1 into ds is s only. This is 9 s cube. Got 2 plus 1 3. Let me write that the same way. This is 2 plus 1 divided by 2 plus 1. Here variable is s. 2s 1 plus 1 plus 1 1 plus 1. This is s here. Plus 16 into s. Called 1 integration
of 1 is s in this case. Now this is 3, 9, 3, 3 the 9, this is 3 into s to the power 3, minus 24 upon 2, that means 12 into s to the power 2, plus 16 into s. Here s is the variable in place of x. So in terms of s, answer will be, the answer is this. This is the final answer of this question number 16 we have done. Let me take 17th question and other questions here. Now question number 17, let me talk about. Question number 17 here, again cube. This is sign of integration a plus x whole cube upon under x here into dx. Okay, so this will be whole cubed. A plus x whole cube, that means we know that right here a plus b whole cube. We know that this is a cube plus b cube plus 3a square into b plus 3 ab square. Okay, this is, or we can write it as a cube plus b cube plus 3ab within bracket a plus b. Solve the process. So whole cube of any function of two, of binomial terms is equal to this. This we know about. With the same formula. This is since this we know. Okay, a plus b whole cube is equal to this much. Similarly, we can write it as opening the whole cube of a plus x. This will be a cube plus x cube plus 3 into a square into x plus 3 into a x square into dx upon under root x. That means x raised power half is in the denominator. Now if I divide each term by x raised power half, first is constant a here, when we are integrating with respect to x, a will be considered as constant. So a cube can be written out of the sign of integration. It's under root x. In the numerator it will come with negative sign, minus half power. Now this is dx. Plus, let me write x cube upon under root x, that means sign of integration 3 minus half power, because this half power will come in the numerator, will become negative 3 minus half power. It will be added. So the x to the power half will come in the numerator as x to the power minus half, then powers are added when bases are same, but if the sign is minus, it will be negative sign. So this is plus sign, plus of dx, plus 3 into a square is constant. Now x upon under root x, that means x to the power 1 minus half into dx. Why 1 minus half? Because half power is this, which will become negative in the numerator. Okay, now the last third term. Okay, the fourth term is 3 a constant sign of integration x square. That means x to the power 2 minus half into dx. Okay, so let me write them as a cube. Okay, this is x to the power half can be integrated, and x to the power minus half plus 1 minus half plus 1. This is plus. Let me first write it. Still, it is not integrated. Let me first write the power of this. What is x to the power 3 by 2? It will be a 6 minus 1 is 5 by 2 positive. It is 5 by 2 power positive. That means 1 and a half, 2 and a half. Okay, because 3 minus half is 2 and a half into dx plus 3 a square x is the positive half. 2 minus 1 is 1.2 into dx plus 3a sign of integration x to the power 3 by 2. 3 by 2 over 1 and a half. For 2 minus half, 1 and a half left over. Now let me integrate them further. This is minus. Okay, minus half plus 1 is plus half. Plus half, 2 will come in the numerator. 1.2, 2 will come in the numerator. 2a cube. X raised for positive half. Plus, this is x raised for 5 by 2 plus 1 upon 5 by 2 plus 1 plus 3 into a square. X raised for half plus 1 upon half plus 1. This is plus 3a. X raised for 3 by 2 plus 1 upon 3 by 2 plus 1. Okay, plus constant can be written that I'm omitting, but that is understood. Okay, now this is twice a cube into x raised to the power half or under root x. Okay, plus this is 5 plus 2, 7 by 2. That means 2 by 7. X raised to the power 7 by 2. Okay, the power is 7 by 2 here. 5 plus 2, 7, 7 by 2. Plus 3a square. Okay, into this is 3 by 2. 3 cancel out. It will be 3. Let me write here 3 into 2. Let me write here 2. Okay, 3 cancel out. So 2 will come in the numerator. X is for 3 by 2 here. So this is plus 5 by 2 here. 2 will come in the numerator. So it will be 6 by 2 into 3. Then 6 by 5a. X is over 5 by 2. Okay, now let me write one more. Once more, let me write it as a cube under root x plus 2 upon 7 into x is equal to 7 by 2. This is 2 plus sign 2 into a square x is equal to 3 by 2 plus sign 6 by 5a into x is equal to 5 by 2. This final answer. Okay. This is how we have to calculate these questions here. 17th question we have done. After dividing by this is the final answer. Now let me take the 18th question. Okay, so question number 18th, what does it say? It says, okay, question number 18th here. This is x to the power n. The same formula which we have applied here, it is used xn plus sin x into dx. Here is the combination of algebraic and a trigonometric function. There can be simply addition of two functions here. It can be written as sin of integration x to the power n into dx, the sin of integration sin x into dx. We know that integration of sin x is okay. Here we know that cos x integration is minus sin x. So therefore sin x integration is minus cos x here. Okay, so sin x integration is minus cos x. That will be let me write here. We got ddx of cos x is minus sin x. Therefore integration of sin x is defined to let me add here. So it will be minus cos x here. The minus sign will come to this side. With the minus sign here, then it will be positive. It will be minus cos x. Okay. Here it is actually for n plus 1 upon n plus 1. Minus sign, this is cos x. Okay, so this is nothing but actually for n plus 1 upon n plus 1 minus cos x. This is one answer. This is minus cos x. Okay, so the answer is this. This is the final answer here. Question number 18 is solved. Now let me take 19th question and onwards. So question number 19 here. What did it say? Sin of integration 1 upon x plus this twice into cos x dx. Okay, so this is what we have to integrate. Now let me write them separately. This is 1 upon x into dx plus 2 into sin of integration cos x into dx. It will be positive. Cos x integration is sin x. I will just define. Now 1 upon x integration, we know that log x, differential of log x is 1 upon x. For integration of 1 upon x is log of x to the base e. This is equal to integration of this. Now this is plus sin. Twice into this is sin x. Why? Let me write here. We know that ddx of sin x is equal to cos x, positive. Therefore, integration of cos x is into dx equal to sin x, positive. Therefore, okay, so integration of cos x is signed as positively. This is positive. This answer. 19th question is solved. Okay, so question number 19 we have solved here. Now let me talk about 20th question. What is the question? 20th says, question 20th. This is sign of integration x minus 2 into x plus 2 into dx. We know that, okay, here we know that in case of algebraic formulae, we know that x plus a into x minus a equal to x square minus a square. Why? We multiply them, we will obtain this. If there is plus sign and minus sign, okay, between two binomial terms, and they have the similar first and second term, then the answer will be this. After multiplication, we can obtain it easily. But this is the formula directly, so we can apply a direct formula. This is sign of integration x square minus 4. A square minus b square, that means x square minus 4 into ds. This is sign of integration, let me write them separately. Minus 4 sign of integration into dx. This is 1 into dx only. So final answer will be x cube means 2 plus 1, 3 upon 3 minus 4 into x. Because 1 integration is x here. This is actually for 2 plus 1 upon 2 plus 1. That means 3. X is for 3 upon 3. This is the final answer. Okay, so this is the answer of question number 23. Question number 20 we have taken. And let me talk about question number 21. The question number 21 says, now here we are entering into different type of questions, which are also asked by the students. Let me take them one by one. Okay, this is sign of integration a raised power 3 into log of x to the base a here. The base must be same. This and this must be same. Then this formula is applied into dx. It can be written as a 3 power, well, we know that, let me define it. Log of a base a x raised power 3 here into dx. Why? Since by logarithm we know that log of m raised power n, or let me write here n, is equal to n log n. Okay, so this n power can be written m raised power n. Here we are taking this 3 to the power of x. A is the base here, that doesn't matter. Now this will be equal to sign of integration x cube only. Why? Let me define it. Since there is a formula that a is power log of a, or let me write something else. We know that k raised power log of x to the base k. Then this is equal to x only. Why? Because this number will come, this value will come of log of which we have calculated. If the base, this power, this base and this base of the log are the same, this is equal to this much. Similarly, this is this formula equal to x. So because of that, this a raised power log of x cube to the base a, this a and a same base, will be equal to x cube only. Now we can integrate this. This is x 3 plus 1 upon 3 plus 1 is equal to x raised power 4 upon 4. Answer, final answer. This formula is to be remembered. Okay, only then we can calculate these questions here. Question number 20 first we have done. Let me take question number 22nd, what it say. Question number 27. Okay, question number 22nd. This is a similar type of question here. This is e raised power 5 log of x to the base e. Okay, this is minus sign e raised power 4 log of x to the base e divided by, this is e raised power 3 log of x to the base e minus sign, this is e raised power twice log of x to the base e
into dx. Okay, so this is the question here. Similar formula which we have tried there. That's okay. Any number. Let me write here a power log of x to the base a. This is equal to s only. This a and this a cancel out. Okay. Similarly, e raised power log of x to the base e equal to x. So that is equal to there. That is how e raised power log of x to the base e. If it is e, then also equal to x. So this is the formula. Since this formula we have to apply here, we can write it as, let me write it as e raised power, this is log of x5 to the base e. We can take this power upon this minus e raised power, this is log of x raised power 4 to the base e divided by e raised power log of x cube over e to base e minus e raised power log of x square to the base e. Now here let me write here, since log of n to the base n equal to n log n, this we know any base is there. So log of m to the base n is equal to log of n into log of n. So n, this power, if it is here, can be taken to the power of n to make it only log. This is what we have obtained. This is equal to log e and log e cancel out. This is x5. I mean, according to the formula, this is x4. Divided x cube minus x square into dx. We can take common numerator as x4 into this is x minus 1 upon x cube. Sorry, x square can be taken in the denominator as common. This is x minus 1. X minus 1 cancelled out. This is dx. This is equal to x raised power 2 only, because x raised power 4 minus 2 into dx. This is x square only into dx. Now this can be integrated with x3, that means 2 plus 1. We write it 2 plus 1 upon 2 plus 1, that means x raised power cube upon 3 answer. The constant can be written or may not be written. Okay, x cube upon 3 is the answer. This is what we have to do. So in this case, this is a separate type of question, but which is having a simplification. This use of logarithm as well as of exponential powers. Question 22nd we have solved here. Now let me take the remaining questions here. The question number 20, we have taken this 20 question number 22nd. Okay, now 23rd question. 23rd question is having some parts, I think. First 2 parts are there. This is sine of integration twice upon 1 plus. This is cos of twice x into dx. Okay, this is there. 23rd, second is there. Okay. Now we know that since cos of 2x equal to, there are three formulae, 2 cos square x minus 1 and 1 minus 2 sin square x. This implies that 1 plus this 1 minus 1 can be taken to the side. It means 1 plus cos 2x equal to 2 cos square x. It's a trigonometric identity. We know this. We have used this number of times in differentiation. Okay, or elsewhere we have taken this. And 1 minus cos 2x, because 2 cos 2 sin square x can be taken to the left hand side. It will be 1 minus cos 2x equal to 2 sin square x. Okay, so now this can be applied here. So what will we get here? Therefore, this is twice upon 1 plus cos 2x. This is 1 plus cos 2x equal to 2 cos square x. 2 cos square x into dx. 2 cancelled out. This is 1 upon cos square x, that means secant square x into dx. Okay, we have obtained this one. Now, since ddx of 10x we know equal to secant square x, therefore integration of secant square x into dx equal to 10x. Okay, ddx of 10x is secant square x. And the integration of secant square x is 10x. The answer here is 10x only. Plus constant can be written, but 10x is the answer. Constant. So 10x is the answer of this. Okay, so final answer is 10x. Now second part of this, let me write what is the second part. Now second part is this second part. Sine of integration twice upon 23rd. Second part 2 upon 1 minus cos 2x. This is 1 minus cos 2x into dx. Now this below 1 minus cos 2x, this I have already defined this now. Answer here from the cos 2x formula. Where cos 2x is equal to cos square x minus 1 or and equal to 1 minus 2 sin square x also. From this 1 minus 2 sin square x and cos 2x, we can take this 2 sin square x to this side, cos 2x to this side, so 1 minus cos 2x equal to 2 sin square x. So in place of this, in the denominator we can write 2 sin square x into dx. Sorry, so this is 2 dimensional. This is second square x into dx. Now what do we know? That what is differentiation of cot x is equal to minus cos x square x. So ddx of let me write here of cot x equal to minus cos x square x. Cos x square x equal to minus cot x. Therefore, integration of cos x square x into dx equal to minus sign will come to this side, it will be minus cot x. But here it is minus cot x. Integration cos x square x dx equal to minus cot x only. So this answer to second part of question number 23rd here we have done. It's another to take just second part of question number 23rd we have done. Okay, question 23rd is completed. Now let me take question number 24th. What does it say? Question number 24th is having only 2 parts problem, but 25th is having 5 parts, 4 parts. Question number 24th, let me check. First part, what does it say? Question number 24, first part. This is sine of integration. This is cos 2x plus cos 2x plus 2 sin square x divided by cos square. This is cos square x only. Then we have cos square x into dx. Okay. The denominator we have cos square x. Okay, so this is cos 2x. This is cos 2x. Is smaller. Let me write it clearly. So this is cos 2x plus 2 sin square x. Now we know that what is cos 2x in terms of sin square x. We know this. Cos 2x is 1 minus 2 sin square x. As we know, plus 2 sin square x as it is. This cancel out. Divided with cos square x into dx. Since, let me write it here, since cos 2x is equal to 1 minus 2 sin square x, this implies that 1 minus cos 2x, or cos 2x equal to, sorry, this we have to use here, only we are using this formula. Cos 2x we have replaced by 1 minus 2 sin square x, which is here, just to remove this 2 sin square x, cancel out. 1 upon only cos square x is obtained. This is 1 from cos square x. This is equal to secant square x. Sine of integration into dx. Now this we know that this is 10x. Since differentiation of 10x is equal to secant square x, therefore integration of secant square x into dx equal to 10x. Because that is secant square x equal to 10x integration. This we know. Okay, so this is what we have done, the first part of question 24. Let me take the second part of question number 24. What does the second part says? The second part of this says, let me write here the second part. The second part says that sine of integration is 2 cos square x minus cos 2x divided by okay, sin square x into dx. Okay, now this can be written as this is 2 cos square x minus sin. Now cos 2x, as I just clarified, cos 2x is having number of formulas. This is 2 cos square x minus 1 is one formula. Second is 1 minus sin square x. This we used in the previous one, the first part, and the second part we have to use this one. In place of cos 2x, this cos 2x minus cos 2x we have to replace by 2 cos square x minus 1. Since from trigonometric identity, this we know, this and this. So in place of cos 2x we will replace by 2 cos square x minus 1 divided by sin square x into dx. This is, now if I open this 2 cos square x minus 2 cos square x, this is plus 1 divided by these two are cancelled out, this is sin square x into dx. Let me replace this. Okay, so what do we obtain? This is 1 upon sin square x into dx. This is equal to cosecant square x into dx. This is minus cot x, we know, is equal to minus cot x integration of cosec. Since ddx of cot x equal to minus cosec square x, this we know, therefore integration of cosecant square x into dx equal to minus sin will come to this side, be minus cot x. Integration of yes. Hi guys, so I was just doing question number 25th here. Question number 25th, first part now onwards. Okay, the remaining questions here. Okay, so what is the 25th question? Now for this condition is given that if a is greater than 0, that means a is positive, and a is not equal to 1, that is given here, a is not equal to 1. Okay, then we have to evaluate the following questions. Then evaluate the following integrals. Now this condition, a greater than 0 means a positive and a is not equal to 1, is just applicable only for question number 25th. That means there are 4 parts here. First, second, third, and this fourth part. Only these 4 parts are including a. For that, I mean, wherever a is included, I mean, only 3 parts are including a here. A is positive and a is not equal to 1. For that condition, this is given. Okay. Then 26th and 27th question. Let me complete them. Now, question number 25th, first part. It says sin of integration e raised power, okay, x into log of a to the base e, log of a to the base e into dx. Okay, this is part 1, e raised power x log of a to the base e into dx. This is given to us. Now we know that this is can be written as e raised power log of a to the a raised power x base e. Okay, because this x power can come, since now we know this, that log of m raised power n equal to n log m. So if n is before the log of m and base is e here, let me take base e. E is natural, okay, base, so we write, or sometimes we do not write it, so that should be understood that its base is e here. Okay, so this base e is there. Now therefore log of m, okay, and power, if this power n is there, so n comes before. Now here it is x is before, so this x can be taken to the power of this value, for of which logarithm is to be calculated. Okay, so this we are having here. Now this is equal to, now therefore e raised power log of e, this e log e cancelled out. This is equal to nothing but e raised power x e into dx, or this is dx. We are integrating this now. Integration of a raised power x is, you know, this is a raised power x divided by log of a to the base e. Since ddx of a raised power x, okay, is equal to a raised power x into log of a to the base e. Therefore, integration of this implies that integration of a raised power x into dx is equal to log of a e to the base can come in the denominator. So this a raised power x upon this is constant here. So constant is log of a to the base e. So it will come here in the denominator of a raised power x. This is a raised power x. Okay, dx equal to this. So therefore dx a raised power x dx is this. And since this we know, okay, and this is e log of e is cancelled out is 1 into a raised power x. That means a raised power x here. So this is the answer of first part. Now what is the second part of question number 25? Let me take it. Question number 25, second part is sign of integration. Okay, e raised power a log of x to the base e, not ds. This is the second part here. Sign of integration e raised power a log of x to the base e. Okay, now again a can be taken to the power of x. This is equal to e raised power log of x to the base a base e. Okay, the power a, this a can be taken to the numerator. This is dx. Now since I have to write it again, n log m to the base e is equal to log of m base power n. Vice versa, if I take log of n to the base n, or power comes before log of m base power n, log m n equal to n log n. Okay, this is what, because of that we have taken this a to the power of this x. This is equal to, well, e log e equal to 1. This is equal to sign of integration x raised power a. Now this is x raised power constant like n, x raised power n. What is integration of that? This we know that this is equal to x raised power a plus 1 upon a plus 1. Okay, only. So this is the answer. X raised power a plus 1 divided by 1 plus a. Thus constant c can be written, no doubt. Here also we could write here constant of integration. This constant of integration can be written as constant. Now we just omit or that doesn't matter, but there is a, okay, this is understood here. Constant must be there. This is understood because the value is indefinite. We are integrating. This is indefinite integrals, okay, not definite integrals. In case of definite integral, constant is not there, but here constant is understood, can be written. For sake of convenience, we can eliminate this, but or we do not write this, but it must be written there. So this is constant of integration. This is the final answer of this. Now third part, let me take for the part third here. Let me write in the above. Okay, top. Let me write it here. This is question number third part. So question 25, part third. What does it say? So part third says, okay, this is e raised power x, sign of integration e raised power x into e raised power x, e raised power x into dx. Now they have the same powers. This is same, so it can be written as e into a whole power x into dx. Now this is nothing but what is integration of e raised power x? The same thing. E raised power x means e a whole power x divided by log of ae or ea. Okay, now this can be written as how? E a whole power x divided by, this is log of a. Now e here is the base, because when there is no any base, we write always e is the natural base of logarithm. This can be written like this. This can be written as log of a, but in multiplying there a into e plus log of e to the base e. This is 1. So this is equal to e a whole power x divided by 1 plus log of a to the base e plus constant c. Here we can write here constant c, constant c, constant of integration. Okay, this constant of integration. This is the answer here. What is this e raised power x, powers are same. You have written like this, these are constants here. We can write like that. Okay, so this is the answer of question number 25th, third part. Now let me take fourth part. The fourth part of question number 25 says, it says that this is sine of integration 2 raised power log of x to the base e, log of x to the base e dx. Okay. Now wherever this power is given to us, we can take it as, okay, now we know that, since we know that y raised power log of x to the base e, if it is there, then it can be written as equal to x raised power log of y to the base e. Base is same. So these can be replaced like this. Okay, so in this way, if I write, since this is equal to this, therefore this is equal to sine of integration 2 can be taken here. This is x raised power log of 2 to the base e. Okay, log of 2 to the base e means now this is power, constant power. What is the integration of this? This is nothing but x raised power log of 2 to the base e plus 1 divided by log of 2 to the base e plus 1. In the numerator, it can be further written as x raised power. This 1 can be written as log of e to the base e. This is log of 2 to the base e plus log of e to the base e divided by, this is log of 2 to the base e plus log of e to the base e. This is 1 log of e to the base e. Base e is like this. Okay, this is log of 2 to the base e. So what is this? Can be further written as x raised power log of 2e to the base e in the numerator divided by, in the denominator also, log of 2 into e. This is a multiplication, this is addition. So when the two numbers are in multiplication, in case of log of m into n is equal to log m plus log n. This can be summarized like this. This is plus constant c here. You can write constant c, constant of integration. Either eliminate this or omit this. I mean, constant is understood. It's indefinite integral. The value is different, not unique. It is different for different integration. Okay, so in this case, this is the fourth question we have done. Now this formula should be understood. Okay, so this is applied here. But we know that pi log of x to the base e. So this can be replaced. X can come in the base and this can go there. So this we know from logarithm. Sorry. So this is the answer of question number 24th part. Okay, now let me take the remaining two questions, which are 26th and 27th question. What is the 26th question? Let me check it. Now question number 26. What does it say? It says that sine of integration under root is 1 plus cos 2x divided by 2, okay, into ds. Now this we know. And what is cos 2x? Since cos 2x equal to 2 cos square x minus 1 equal to 1 minus 2 sin square x. In this case, we have to use this form. This minus 1 can be taken to the side. This implies that 1 plus cos 2x equal to 2 cos square x. Okay, from this, since we know this and this is there. So, in place of 1 plus cos under root 2 x equal to 2 under root 2 cos square x, we can write here. Therefore, this is equal to, within bracket, is equal to 2 into cos square, sorry, cos square x only, not 2 but cos square x, okay, divided by dx. Now this is under root 2, this is 2 2 raised to power 1, so under root 2 will come in the denominator. This is 1 upon root 2, while this power is 1 minus half power of 2 will come here. This is cos x only into dx. What is differentiation of, sorry, integration of cos x? Is sin x. This is into 1 upon root 2 into sin x plus constant c, while since ddx of sin x equal to cos x. For integration of cos x, it's implied integration of cos x into dx equal to sin x, positive. So integration of cos x is positive sin x, but we know that differentiation of sin x is positive cos x. Okay, so this is the answer. Okay, this we have applied here. Okay, so this is differentiation. Now integration of under root 1 plus cos 2x upon 2. Question number 26. Now let me talk about question number 27. So what is the question number 27? See, this type of question we have already calculated or we have done. We have solved the question. I think this kind of question was there in the joint ratio. 26 and 27 are of similar type. Let me take the last question, 27th, sign of integration. This is e raised to power 6 log of x to the base e. The minus sign. This is e raised to power 5 log of x to the base e divided by e raised to power 4 log of x to the base e minus e raised to power 3 log of x to the base e. Okay, so 3 okay, log of e dx. This is integration of this whole with respect to x here. So we know that this can be further written as e raised to power log of x to the base power 6 base e minus e raised to power, this is nothing but log of x power 5 base e divided by, this is e raised to power log of x 4 base e minus e raised to power log of x over 3 base e, while because since n log m is equal to log of m whole power n. This we know about. This power can come to the, okay, or this number can come to the power of this. Okay, so log of m whole power n, or log m n power n equal to n log n. This is just like that. This power, this 6 can come to the power of x, 5 can come power of x. Similarly, 4 has also come power of x. Now e log of e is 1, so we just equal to nothing but x6, this is x5 divided by x4 minus x3 dx. Okay, so this is equal to, we can take x5 common, this is x minus 1, x3 common, this is x minus 1, x cube we have taken common from these two, the denominator, so only x is left over minus 1. Similarly x5 we have taken common, this is cancelled out into dx. This is equal to x raised to power 5 minus 3 into dx. That means x square into dx. Now this integration we know that is x plus 2 plus 1 upon 2 plus 1 plus constant c. This is x cube upon 3 plus constant c. Constant c be right or do not right, that doesn't matter, but constant is not a matter of, I mean, any difference, but it is understood. If it is not written, that must be there. We should write that it is understood here, a constant is there, because unique value is not there in case of indefinite integral. We are finding out indefinite integral here. So this is x cube upon 3 plus c constant. This is the last question, 27th. Okay, this is for today here. So this is the 27th last question.
exercise complete now. Okay. See you in the next lecture then. In the next lecture I'll talk about further what are the other methods for this, and then maybe I write some formulae which are important formulae for this from differentiation and comparative study. Comparative formulae, they are very much useful for integration. So for next integration means for we take extensively the integration of next topics here. Those topics are very much extensively covered. Before that I'll write down some formulae, but I think next lecture, in the third lecture, I'll write down, or before the third lecture I'll note down all the formulae which are important formulae. Okay, so that we can understand that okay, this is this. Because now we are writing differentiation simultaneously than integration, and we know that from differentiation this is equal to this. But in the next lectures, I mean in the extensive lectures, or when we study the other difficult topics, so in that we will directly use the integration. That we know that this is integration. We are not writing region that y differentiation, this is integration. So comparative differentiation, we will not write them. So for that, okay, we have to understand that what is the integration of this particular function. So that all those formulae I'll try to note down so that you can understand that these are the important formulae. Okay, so they are very much helpful here. Okay, then see you in the next lecture.